everybody. Welcome to Extremely Open Science. And this is stream 25 of season 2. So we are going to pick up where we left off. So actually last week, and for those who did not see the recap, so last week I made a small blunder on stream where I was comparing nucleotide sizes to amino acid sizes, and obviously they are equivalent but off by a factor of 3. So I compared the nucleotide sizes of genes to the expected background in amino acids. So it seemed that the genes were all very, very large because they were in fact 3 times larger. So if a gene of 100 amino acids has 300 nucleotides. So that was a bit of a blunder, but we are now ready to move on. So I am going to start sharing my screen. There you go. And so again, let me start running this because this takes a little bit of time. I'm going to set these to false here. This takes a little bit of time. Okay, I'm going to start. All right, as this is running, I'm just going to walk you through what we were doing. So we don't want these things here. So again, everything we've been doing here based on simulating mutations. So we load the results, and then we load the results from mapping to GMGC v1. So those are our background. So it's actually the it's the GMGC v1, the complete gene subset. So those should be what we expect to get, and so we load this, we filter, so we get only OGs, orthologous groups with at least 100 genes. Then we do these, we sort of just get the sizes, and then this is where I got messed up last time. So we get this table with the sizes of mean and standard deviation, right? So this is what we had, and then there you go. It's going to be a figure where we look at so we load the outputs. We do a fair amount of sort of games there to get the mutations, and eventually convert everything to z-scores. So this was one of the ideas where we get these z-scores. So the size of a gene. So if a gene is 300 amino acids, and that is in OG 1 to 3, then we can check what's the average and standard deviation for genes tagged as 1 to 3 in the GMGC. Use that as a background, and then eventually we got to this function that has, or this score, extra short gene score, where basically we just sum all of the values, all of the z values below -4, right? And here, and I show this on the, I'm going to show the results. I'm going to just show the results. So this is what you get when you do all of this computation, namely where you have, so here these horizontal lines, and you can see a few that are relatively low, and then but then they all go down quite substantially as the number of mutations increases. And also I share this is the comparison. So on the left side, this is what we had before using the values from CheckM2, its annotations, and here on the right side is what we have now with Eggnog Mapper. So this is an ugly figure, so just copying and pasting 2 figures to be next to each other. But you have see the idea that does seem to be fewer of these horizontal lines that are very low. So there's a much more separation. See here on this right hand side, you see a lot more separation. Here there's still some overlap. So I think this is much cleaner now. All right. So having said all of that, this is now gonna run. This is so this takes a little bit of time, but there's a couple of things that I wanted to see, and so maybe we can actually so the first one, I'm going to load this in a second. So I'm just going to load. So a couple of things I wanted to check here. So first I would just want to see if we can do a better job of visualization. So I like working on visualizations. So, but that might take a while. Instead, let's work. Let's work a bit. Also, I'm not sure I like this loading everything all at once. Maybe we can make this into a jug task, and then we just need to load the results. Maybe, for example, maybe this OG sizes, could this OG sizes be a jug task? You know, it takes it's not terrible. It takes what, like a minute there, but maybe we can just save it. Right, this is what we will do. Yeah, there it is. Okay. So what do I want to do here? So the other thing we had tried, the other thing we had tried at some point was instead of use, maybe at some point was to, okay. All right, so something's, oh, this is interesting. So one thing we had tried was to check whether so we've been using the GMGC, but we could also use actually the genomes themselves, the versions without any mutations, and that could also be a potential source of a background distribution. I was trying to avoid it because there are some issues with wait. So I don't know what I'm doing right now. I'm waiting for this to run, which is gonna take a bit. Maybe I can interrupt it. How to interrupt it? Oops, sorry, that's not what I meant. Sorry. I'm gonna just interrupt that one. Okay. Alright, so it's not bad. Alright, so so I'm a little bit scattered as usual. But let's see. Why is this so slow? First of all, it should always be nicer if this is faster. Okay, that part is fast. Loading. Okay, loading the results is slow. And if that's the case, there's really not much we can do. I think Jug is so Jug is right now not treating the polars object, so it treats NumPy objects specially, but I think as far as I understand it does not, well, as far as I understand, I know because I wrote it, but it does not treat polars objects correctly, or specially, it just pickles them, which works perfectly well, except it is a bit slow and I am a little bit surprised actually at how slow it is, but maybe also something that could be fixed. Alright, so we okay, this is very fast. So what? Wait, Arna. So okay, let me just see a couple of. I always forget if it's 1 2 or 2 1. Yeah, that's correct. 1 2. No, I want the left one, the first one, to be shorter, so that's ratio something. Oh. Yeah, something like that, yeah. Yeah, something like this, actually. Let's do this. Okay. Okay. Let's get rid of everything else. Let's keep that one. Yeah, something like this, except on X. What am I looking for? I'm looking for a strip. Let's see what that does. Actually, this is not bad. Okay. Okay. Yeah, this is something like this. Okay, it's a bit better. So yeah, I also want it the other way around, right? Also want it the other way around. So if I have so I want it the other way around, right? If I have let's say eventually we would have some sort of thresholding type thing, right? So if I set the threshold, let's say minus 200. What am I thinking about? So if I set the threshold, let's say minus 200. Actually. So I'm gonna do something here in the other window. I'm gonna just run the whole thing. I'm gonna explain why in a second. Actually, I want to have the ESGs. All right, yep. I want to have the ESGs to play around with. So this. Okay. All right. So here's what I'm gonna do. Okay. Here's what I want to do. Oh, this is okay. I actually knew about this. Alright, a little bit. Okay, so this is what I want to do. I want to so this filtering here and all of this reorganization, let's move it to a task. All right, let's just do this way. All right, we are moving this to a task here. Okay, not great because we are still going to be. All right. Okay, we can. How about this? So we just make it into a task, and then here we load it, and this should be faster. Yeah, this should work. Okay, and now this is going to take a little bit of time, but it will run one time. So this will run one time, and now, so this is not an uncommon thing for me to work on, which is first time we write code, it just runs. First time we write code, often it just runs on the terminal. Eventually, it moves to being a sort of a script, and then finally it ends up in the jug file so that the results get cached. So okay, let's not keep that one. So now, so today is the 20th. So So right now this is just a refactor. I think that was a bit too long. It's going to complain. To chat. I'm just going to say to chat. All right. So that was the first thing. There it is. Okay, actually that should not have had the okay, now it's a bit let me just double check what it's doing. Oh, it's loading. No, it's parsing the file, the length of the file. Oh, it's building the length thing. Okay. I'm just gonna save it for now, just for okay. Oh, this is a little bit slow. Okay, so at one point I managed to crash my computer while running OBS, and then everything crashed, and that was actually a little bit embarrassing. So let's see if let's hope that this doesn't happen today. So again, I think this was running this exact thing, right? So OBS is running, Jug is running to do that thing. Okay, no, I don't want that. No. Move. Okay, so let's think about where would be a good place to stop here. Okay. Yeah, I think that. I mean, partly I think we have a. So I think we. And maybe I will do that, which is, I will. I want to. So Polar's. The pickling is a bit slow. And so ideally So what I'm trying to figure out is, okay, so right now the way we had done this is that, you know, this would be running, this would be, so everything else is cached, and then this runs step by step. But then I think, okay, maybe some of this could be moved to a jug command, to a jug task, and then we could potentially also run it very using all of the jug goodness, namely parallelization, and that would save, you know, that would save us a lot of compute. I'm just gonna but I was trying to think, what would be the good filtering here to have? So all of these things here. So if loading, if it's actually just loading the whole thing, all right. Annotation, okay. Yep, so now it's just but if it's loading, that's the bottleneck. It's not gonna help much. Oh, okay, I actually know what I want to do. Okay, this doesn't exist. Oh, actually. Actually, this one should be. No, whatever. Okay. I'm just gonna preload some of these here. Right, so just by running jug value, it loads the value and then it actually keeps it in memory. So in a couple of minutes, once the other task is done, I will be able to just have access to it, to just load it. But in the meanwhile, it would actually, this takes a long time. And so one thing that's a bit annoying is that I'm never really 100% sure what is the perfect sort of so what is the perfect output in format, like so is it Parquet? So ideally it would be format, very fast to read and load, supports everything in a sort of one-to-one support. Like what's an Apache Avro file? Okay. Right, does Parquet support everything that Polar supports? So I would want something that I save a Polar's object to it, I read the Polar objects, and I get exactly the same thing. Is Parquet that thing? It might be Parquet. So maybe and I'll work on this off camera because it's not sardine related. Maybe Jug should support this, because Jug supports. So when it's a NumPy object, Jug does not use pickle. Jug just uses it saves it to a file. It's much better. So maybe this is what. In which case this would, this shouldn't take 30 seconds to load. Right. Let's see. Right, let's see. This is partly why I like to run things on the command line myself. Gives you a very intuitive feeling for what's taking a long time, right? This took. Yeah, all right. See, this is what it should feel like, right? So. Okay, it's a PAR one. Okay, maybe Jug could potentially support this. This would actually be cool. Let's. And then this takes a few seconds. This is fine. Takes a few seconds. This is fine. Okay. All right, so we have 15 minutes. Sorry about that. I should have muted myself. Actually, that's incorrect. It should be. All right. Okay. It's not 2 CSV. Is it right CSV? Yeah, it's right CSV. Okay. So this is gonna take a. We're almost. Okay, there it is. Okay. Oop. By the way, just double checking. Yeah, okay. So just checking, so the contents of the files are the same. So we can, so this, let's interrupt that again. And now we have all in. No, wait. Just want to get a few in. Okay, all right, so this is all right, so let's see. So if we have all so I think I should compute all z-scores. I should jugify all z-scores, the z-scores computations, because if I do that, then I think then it will be, first of all, I can compute the ESGS, the extra short gene score, relatively easy. So I need the emapper out and the OG sizes, right? And the gene positions. Okay. Okay. So this here, this is where. Okay. Just do this. Not great, but no, let's do this. But this could work. Okay, but okay, let's see. Okay, so if I do this way. Okay. So in principle, so if this works, then I should be able to right, and this is actually a very common, as I said, this is a very common thing. We first run it in a script sequentially, just one after the other. Realize it's a bit slow. We want to keep reusing the results. We put it into Jug, and now we have all of the Jug goodness in terms of parallel access, etc., etc. Let me just see how this is going. Okay, so z-scores. How do I check? Okay, right, so this is actually, so we could Okay, so this would work. All right, so this works. Let's just wrap it up now. Okay, actually. So this is still part of the this is actually still making the previous okay, right. I think from here, yeah, so this will be much better now. I'm also much more confident that this is the right direction, that we will want something like this. So so just by doing this, and now I can run a few of these jobs in parallel. I'm gonna push to Git. So I just push there to Git, and there it is. So everything's on Git. Right, so let's wrap up for here. Everything's on Git. I'll post an update to the mailing list, a short recap video as well. And I will see you all next week. I'll have also some news for something slightly different that we'll be doing in June. I will wait until it's publicly, available to let you know about that. But in the meanwhile, follow us on Git, subscribe to the mailing list, join us on Discord, and talk to you soon.